In the system of equations above, a and b are constants. For which of the following values of a and b does the system of equations have exactly two real solutions? We're given two equations, and from the answer choices A, B, C, and D, we need to select the one pair that results in exactly two real solutions. Before we understand what we need to do, we need to understand what is a real solution. So a real solution is the one that results in a real number. And a real number is basically any number that we normally work with. They can be positive or negative, they can consist of whole numbers, decimals, and so on. The only numbers that are not considered to be real numbers are those that fall in the category of imaginary numbers. And an imaginary number is such that when squared, it results in a negative number. As we know, any normal number or real number that we deal with when squared should always be positive. However, in math, there is allowance for an imaginary number where that would not be the case. It will become more obvious as we evaluate our answer choices. Before we go to the next step, let's first look at the two equations provided. Since y equals 3 and y equals ax squared plus b, it would make sense for us to replace y with a 3 in the quadratic part. And so what we get is 3 equals ax squared plus b. And since we will be plugging in a and b, there will be only one unknown x that we would be solving for. Let's evaluate answer choice A with a being -2 and b equaling 2. What we have is 3 equals, in place of a, it's -2x squared plus, and in place of b, 2. To isolate x squared, the one that we're interested in, we would need to use manipulation and reverse the addition of 2. So let's subtract 2 from both sides. And what we get as a result is -2x squared on the right-hand side equals to 1, which is the result of 3 minus 2. Now, let's reverse the multiplication by -2 on the right-hand side to isolate the x and divide both sides by -2. As a result, we have x squared isolated, and on the left-hand side, we have -1 divided by 2. As we know, any real number when squared should give us a positive result, and what we're facing is the other case, and x squared has a negative value, which means the solution x is an imaginary number. This disqualifies answer choice A. Let's take a look at the answer choice B. Referring back to the equation in orange, we will plug in for a -2 and in place of b, 4. What we get is 3 equals -2x squared plus 4. To isolate x squared, we first neutralize the addition of 4 by subtracting 4 from both sides. And what we get is on the right-hand side, -2x squared, and plus 4 and -4 cancel out. And on the left-hand side, the result of 3 minus 4 is -1. Now let's reverse the multiplication by -2, and we will divide by 2 both sides. And what we get is on the right-hand side x squared, and on the left-hand side we have -1 divided by -2, which means that we have a positive 1/2. The two solutions would be positive square root of 1/2 and a negative square root of 1/2. And we need to account for both, because both negative and positive numbers, when squared, result in a positive answer. So that we have 1/2 in the positive form means we have two answers. Evaluating answer choice C, we have A of 2 and B of 4. Of course, we could stop at the answer choice B because it does satisfy our requirement of having two real solutions. But just to be sure, let's quickly do answer choices C and D. In that case, plugging in A and B, we get 3 equals 2x squared plus 4. Again, we isolate x squared. We get 2x squared equals -1, and x squared equals -1/2. Just like answer choice A, having the outcome of squaring of x being a negative number means that x is an imaginary number and does not satisfy our requirements. And answer choice D of A equaling 4 and B equaling 3, when we do the math, our x squared results in 0. And in this case, we have a real solution of 0, but our problem asks us which one has exactly two real solutions. And answer choice B is our final answer.